Now let's take the fourth program. I know that we did this inside the lab, but I just felt that maybe for those who didn't attend, maybe this is a good thing. If you understood the factors, then just you can skip that, right? So let's take the factors iteratively first, right? I think we don't need any of these, so let me just, right. So the factors iteratively. I'm not gonna go through the concept because we know this. This is not something new. We did this in lab 2.2, so just go to the videos where we introduced that factors thing, right? So if I want to get the factors for 12, right? So I'm just gonna try to divide 12 by any number that is less than 12, literally. I'm going to divide 12 by 12. Is it divisible? It is divisible. So 12, the denominator is a factor. Now divide or try to divide 12 by 11. Is it divisible? It's not, so 11 is not a factor. Now divide 12 by 10, not divisible. By 9, not divisible. By 8, not divisible. Until you reach 6. So this is going to give you 2, right? Is it divisible? Yes, it is divisible by 6. So 6 is a factor. And 4 is the same thing, 3 is the same thing, 2 is the same thing, and 1 is the same thing, right? Notice that n does not change here, right? I need n to be as a whole and try to divide it by the numbers that is less than n, right? So let's say for I in range, right? Starting from 1, because you don't want, notice that I is going to be the denominator, right, that you are going to divide on, right? So you don't want to have the divisor to be 0, because it's going to give you the dividing or the division by 0 error. And we want to go up until n, right, with a step of 1. So let's say if n is divisible by I, then this means that I is a factor, and you're gonna see that these are the factors of 12, right? If we wanted to do the same thing, the exact same thing in recursion, let's see how can we do this. All right, so I would start off by saying, for your information, we don't really need the call stack here because this is really straightforward. This is one of the problems that you can just convert from iterative method to a recursive method, and it just work without using the call stack. But anyways, I'm just going to make some tracing at the end of this video once we've done, once we do the recursive technique, right? So let's say define facts, right? And it's gonna take an n, and notice that I, which is the main source that I'm using here to divide, right? I'm just gonna use I here, right? And start I with 1, right? Since I started I in the for loop by 1, right? And notice that you stop when you reach n, when I reaches n, right? So if I became equal to n, I'm just gonna assume that this is what should be printed. So I'm just gonna return nothing, right? This is new to you, right? Because this is one of the programs that actually prints. Notice that in the question I'm saying that I want you to get the factors, a version that prints and a version that returns a list. So we are taking the version that prints at the beginning, right? So basically, if you put this inside the function, or if you just looked at this code right there, this code does not return any value. It just prints the values to the screen, right? So if we found out that I is equal to n, we kept incrementing I till we reached that I is now, for example, found to be 12, which is equal to 12, the number that we are trying to get the factors for, then this is an indication for me to just terminate the program. And by terminate, I mean return nothing. You can just actually wrote this. You could have just wrote return nothing. It's the same as returning none, right? So return none here in this case would serve as terminating the program, just terminating, literally the purpose of terminating a program. That's it, right? Because I don't really care about the returning, but what I care about is what I'm going to write here right now, right? So if n was divisible, notice that it's the same thing. I can't just take it, copy and paste it like that. So if n was divisible by I, then I'm just going to return I. This is or print I. This is the core of the program. That's the core of the program. That's it. I just need to print. I don't really care about returning any values. So that's why when I reach the base case, what I can do if I'm just printing, the sole purpose of this recursive function is that it prints then I just can terminate the program by returning nothing, right? But let me just do something. If I terminated the program, let me just leave it as this. But you can tell if I became equals to 12, maybe I wouldn't get a chance to print that divisor, that factor, which is I equal to 12. Right? So this needs to be changed. But for the time being, let's just continue. So one would say, where's the recursive call here? The recursive call is simply by calling the facts one more time, right? Like that, just like this, right? And passing to it I, but the parameter, one of the parameters needs to be changed. And in this case, it's going to be the divisor. Where is the divisor is going to be, like the loop here is going to start with 1, incremented by 1 to be 2, 3, 4, 5, 6, up to 12, right? So if we run this program and try to call the facts function and we passed something like 12, it's going to give you all of the factors except 12. And this makes sense because the print here is after the base case. So if you want to include that last divisor, you can say something like this. If I is greater than, and if we found ourselves having a divisor that is greater than the number that we are trying to get the factors for, then this is an indication for you to terminate the program. And this is going to get you the all of the factors of 12, right? All right, let's trace this code right there, and let's take a similar example. Let's take 4 for example. So we know that 4 is going to have 1, 4, and 2 as factors, right? So let's see what will happen. Let's say that we are calling the facts with 4. So this is my I'm just gonna do these things here. Right? So we are calling facts with 4. So here, notice something. Let me just pick a smaller version. So we are calling facts with 4, right? So this is facts, this is a recursive call 1, right? Facts with 4. Note that n is gonna be 4 along all of the stack frames, and I, which is not mentioned, not passed as an argument, an optional argument, starts at I of 1, because we want to be having the same number included when we divide 4 by 4, right? And when the same thing when you divide by 1, you want to get the same number, right? So here we have I started at 1, right? So the base condition is that if I, as you see here, if I became greater than n, right, then we are just returning none. This is, I'm tracing this just to discuss with you what return nones actually means. And there's an if statement that's saying that if n was divisible by I, then we would print that I. So I'm just gonna have my screen right there, or terminal, right? So in the first function call, let's see what will happen. Notice that there is the recursive call is down there, but there's no return because I don't really need anything returned from each of the recursive functions. I just care about printing. This is what I typically want to happen. Just print the values, right? So we're gonna call n with modifying the I every time we call that function, right? So the interpreter is gonna run this for the first recursive call. It's gonna check this if statement is not gonna apply, right? And this if statement will work since n is divisible by I, right? If you divided 4 by 1, it's gonna get you 4, so it's divisible. So it's gonna print at the beginning what? It's gonna print 1, right? So we're gonna go to this one, which is a new recursive call, right? To facts that has 4 and I is incremented by 1, as you can see. So this is gonna have I that is equal to in this case 2, right? So n is 4 and I is 2 in this case, right? The if statement is not gonna apply the base case, right? But we're gonna check, is it divisible? Well, yes, it's divisible, so print that I, right? So it's gonna print 2, right? And then we're gonna find another function call to fact, sending the same n and passing I plus 1. So this is gonna have I of 3, and we're gonna have n just as the same as 4, sorry, we decided that we are passing n as 4, not 12, right? So we are calling facts again with n that is equal to 4 and I in this case that is equal to 3, right? So this condition is not going to apply. I is still less than 4, right? And here is n divisible by, is it divisible by I? Well, yes, it's divisible by I. Since 4 by I'm sorry, 4 is 4 divisible by I. 4 is not divisible by 3. So this is not going to happen. So we're not going to see anything printed, right? So now there is another function called to fact, where you pass n, right, and you pass I plus 1, right? So this is going to call fact for another time, where n in this case is the same as 4 and I is incremented by 1, and this is n, which is 4, and this is I, which is 4 as well. So are we greater than I? Is I, or I is greater than n? Well, no. So is n divisible by I? Well, yes, 4 divisible by 4, then print that I, that divisor. So it's gonna print 4, right? And there is finally another recursive call to n and I plus 1, right? So this is gonna call the facts or fact with 4 and I that is equal to 5. So I now is equal to 5. Is I greater than n? Well, yes, 5 is greater than 4. Then just return. Notice when we return here, this is the most important part. Then return none. So what is going to happen here? What will be happening is the following, and just focus on this part, right? This is going to return none. Right? So this none, when this function returns none, is going to pop out the stack. And it's going to return none in place of the function call. So this is going to have none, right? Notice something. Once this base case, this is my base case that I've had, right? Once you finish that base case and return to the previous one, the recursive call that is literally the one right before the base case, you're going to see that here this base case does not execute. So this return here, there's a return here, that a temporary return that is not going to execute. This base case that has the temporary return or the conditional return only happens when you are at the final or the base case, right? But one would say, what will this function return? Well, we understood that this returned none since there was a return none statement, a conditional return statement. But what would this return? Well, I do not see something like return before the function call, so that's a little bit different than the ones that we had before. Well, if you didn't see a permanent return, like there is no return here, there is no return here, there is no permanent return, there is only a conditional, return that is going to happen only if you are at the base case, right? But we do not see any return beside the function call. So this means this is the same thing as saying that this function has no return, or in other words, this function returns none. It's the same thing, right? So this function is going to be placed with the none returning from the previous base case or recursive call, and this function is going to terminate once this line has a value that's going to be substituted with none, right? So this is going to be substituted with none, and hence the function call is going to pop, and this function returns nothing. There is no permanent return, so it's turning none, right? And why is that? Because I told you that we are focusing only on printing. That's why our base case, that's why two things happen. My base case, I only focused on returning none here just to terminate the program, right? And I focus on not adding a permanent return statement beside my function, my main recursive function call, because I don't really care about what's being returned. I just want to print. This is my main goal right there, right? So this is gonna be popped, right? And in place, notice that this was triggered from this guy, from this line right here, right? So the control flow is gonna go back to this stack frame, and instead of it, since this function returns nothing, right, is gonna have none in place of that recursive call. So Once this line finished executing and none is substituted with that highlighted function call here, right? So this function is going to be popped, returning none to the place where it actually was triggered from, which is in this case this stack frame, that the one that is right before of it, right? So this is gonna return none. This is returning none from here, right? And in place of that recursive call, we're gonna have none. So now there's no lines to execute in this function call, so we're done. Let's pop this and return nothing, since there's no permanent return statement. Let's return none to this, to the place where we actually have triggered that function or that stack frame from, which is in this case this line. So the control flow returns here, and this none is being placed into this instead of this function call. So we substitute none here, right? And there's no line to execute afterwards after this line, so this pops of the stack, returning none because there is no return in it. And finally, we have this printed to the screen. If you try to add a print statement to this, you're gonna see that none is being printed, and that last none is basically this one that is being returned from the last or the first recursive call, right? This is the first recursive call. Okay, and this is it.